ready, set, pipette. But make sure you do it right. So today I just thought I'd go over how to properly use various types of pipettes to make sure that you are getting accurate volumes and that sort of thing. So we'll talk about multiple types of pipettes. We have the traditional like micropipettes that come in a variety of different sizes with different size tips. We have like the serological or like volumetric pipettes where they have bigger sizes like 25 mils, 5 mils, 25 mils, 50 mils, etc. When we're talking about the micropipettes, these just go up to like 1 mil typically, and then others go up to like 5 mils, but typically they're smaller volumes. And we also have like multi-channel pipettes, which have like the micropipettes, but allow you to do multiple steps at the same time. And then repeater pipettes, which let you go do the same volume over and over and over. So micropipettes are probably the ones that you're going to use the most, depending on your lab and that sort of thing, of course. If you're doing a lot of cell culture, you're probably going to be using a lot of the serological pipettes. And if you're doing a lot of high throughput, so lots and lots of samples, types of things, screens, maybe, you're probably going to be working a lot with the multi-channel. The repeater pipette's really great for making lots of aliquots. With these, with any of these pipettes, you're always going to want to choose the smallest tool that will hold the volume that you want. So for example, these micropipettes come in a variety of different sizes. We typically refer to them by the name of the largest volume that they can hold. So for example, a P1000, 1000 is referring to 1,000 microliters. A microliter is 1,000th of a milliliter, which is the 1,000th of a liter. So 1,000 microliters is going to be a milliliter, and we call this a P1000. We can see here, oh, this isn't the P1000, so this one's the P1000. And so you can see this is 100 to 1,000. So this means it has a working range of 100 microliters to 1,000 microliters. But if you wanted to pipette 100 microliters, you'd be much better off using the P100 or the P200, which goes up to 200 microliters and between 20 and 200. And if you wanted to do 20, then you could do a P20. And if you wanted to do 10, you could do a P10, etc. And you always want to use the smallest one for a variety of reasons. It's going to be the most accurate. Basically, yeah, it'll be the most accurate, and you'll have the least loss and various things like that. So you always want to use the smallest volume. If you look at one of these pipettes, you'll often see there'll be a line or there'll be different colors. So here they're different colors, and you can see this one. So this is the P20. It goes to 20 microliters, and from 2 to 20 microliters. If you look over here, you can see that it's set to 11. Let's just, okay, I have to make this easier. So it's set to 11, and then you see this red, the 0 is in red. This is telling me that this is 11, and the red is after the decimal point. Sometimes you'll see there'll be a line, and then what's under the line is going to be under the decimal point. If I look at a P2, it's here. I go from 0.1 to 2 microliters. And you can see here there's 2 red digits. So this is telling me I can get 2 units after 2 like significant figures or whatever, 2 more digits of precision with this pipette. Whereas with this one, I could go 1 after the decimal point. And if I were to go to a P1000, well, now I can't go anywhere after the decimal point unless I'm below 1,000. So you can see if I go to 1, then the 1 is before, and then you have 2 after, but you can't go after, so all you can do is go below, and so you're always going to be working below that decimal point, or below that decimal point, which is if you're working in like microliters, because that would be in terms of milliliters. That would be 1 milliliter if you were above that decimal point. I was saying that part really weird. Basically, if that decimal there is in terms of milliliters. So you're always you can't go above 1 milliliter with one of those. So when you're at 1, the 1 is going to be before the decimal, and then the zeros are after the decimal. But typically, when you're working with that pipette, you're going to be working below 1 milliliter, unless you're at its limit. So there are typically 2 2 points after the decimal in the P1000s. So that's going to be like, if you're at 0.62, that's telling you that it's at 620 microliters. And so with the P1000, you're only able to get to within a microliter of difference in your volume. Often that is okay. If you're using larger volumes, it's okay sometimes if there's a little more, like if it's not as accurate, if it's not as precise as when you're working with small volumes. When you're working with small volumes, the tiny little bit of difference is a large difference, like ratio-wise or whatever. But if you are pipetting a large volume of something and you have a little bit of a difference, or you have a little less, a little more, that's really not that big of a deal. And so it depends how precise or how like you need to be is going to depend on like the experiment and that sort of thing. If you need something where you need a larger volume but you need it to be more precise, you can always like do it twice with a different pipe with a smaller size pipette, that sort of thing. Of course, then you have to worry about losing, every time you transfer something, you have the potential to be losing liquid on the sides of the pipette. But you can't do that. To adjust one of these, they often have a lock, so it'll be tight to make it harder for you to accidentally like turn it. But then you can just unlock it and turn the dial until it's where you want, and then make sure you lock it back up. When you're pipetting, you probably have a tendency, I know I do, to like accidentally turn it if it's not locked in place. And so another good practice is when you're pipetting to periodically look and make sure that you haven't shifted the dial. This can happen really easily, especially if you're pipetting a lot of samples like over and over and that sort of thing. I always check to make sure that it hasn't turned, because then your sample volume is going to be off. Another thing when you are pipetting is you want to make sure that, I know it sounds stupid, but you want to make sure that when you're pipetting, you actually see that there's liquid in the pipette that's coming in and it's going out. So it's really easy, especially when you're working with one of the small volumes, to kind of like just put your pipette in here and think you drew up the liquid, but really you just drew up air. And so you want to take a look and make sure it's really in there, and then also that when you're releasing it, it's getting all the way out. You're releasing it all the way out without accidentally just like sucking it back up. So you want to work, you don't want to work too quickly, and then just like pull up and it's still in your pipette. Speaking of pipetting, more on this in another post, but typically with these pipettes, we're doing forward pipetting, where we go down in, so you push down, go into your liquid. So you push down to, basically there's a first stop and a second stop. The first stop is going to be when you're measuring, so you go down to the first stop and you pull up. Now you pull out. After you want to make sure the liquid goes all the way up. You want to put your pipette just in the top of it. You don't want to get excess liquid stuck on your pipette tip. You pull up, and then you pull out. And you go where you want to deliver, and then you're going to push down. Now you go all the way to the second stop and make sure it all comes out. Then with your thumb still down, pull out and release your thumb, and there should still be nothing left in your tip. And so more on pipetting, especially with viscous liquids, in another post. There's another thing called reverse pipetting. There's where you go down to the second stop, all the way, you push all the way down to the very end, and then you draw up. Now it's going to draw up more liquid than you need to push out. When we were doing the forward pipetting, we needed to push all that liquid out, similarly to how we needed to push all the liquid out when we were using one of these serological pipettes, unless we were just going from between these different lines. But if we're going to use that bottom, the full volume that we've measured, then we're going to need to blow it all out. So with this reverse pipetting, now I have extra in here, so I don't want to blow it all out. Instead, I just want to go to that first stop. And this can be good when you're working with really viscous or like syrupy solutions, as well as things that are like volatile, so like ethanol and that sort of thing. Another good practice when working with those is to pre-wet your pipette, so to like go up and down a few times. This is going to help equilibrate the pipette with like the gases and stuff from the volatile when you're working with those. No matter what type of pipetting you're doing, it's important to avoid bubbles. So say you're using a micropipette and you have some sample and you don't want to suck all of it, or you want to suck all of it up, and this is a bad example because I have way too much liquid in here. But so you can set your pipette to a larger volume than you would actually need to pipette it up, but you don't want to just like go in and suck it right all up. Instead, what you want to do is just go till you're like right at the bottom, like just have a little bit of air, something like that. And if you don't want to pull all the way up, because then you're going to introduce the chance of having bubbles form. Speaking of bubbles form, you would not want to just like do what I just did, where just like that. See, now you get like splashback. You want to go slow and steady, both in and out. When you go out, you want to go onto the wall of the container, or you want to go into the surface of the liquid you're pipetting. Use the surface tension coming from the like interactions between the liquid in your pipette and the liquid in here, or the liquid or the surface of the tube, to help draw things out. When I talk about like going slow when you're pipetting, this is especially important if it's viscous. You kind of get a feel for the flow of the liquid. So watch it when it's coming up. If it's behind your thumb, so if it's coming slower than your thumb, you need to slow your thumb down. So if something's really viscous, it's, even though your thumb might be all the way up, it's still drawing up. So you want to go kind of like watch it and go with the flow of the liquid coming up of the pipette. So when you first start out pipetting, it can be really shaky. So you can, one way to help, especially if you're like loading a gel, you can kind of support it with your other hand. Over time, you'll get a really strong pipette thumb. So I think we could all, like scientists, we could probably win some really mega thumb wars. But yeah, so it just takes practice. It's a skill, and you'll get a sense for it, get a feel for the liquid, get a feel for the first stop, the second stop, down to the first stop in, pull up, and take out into the liquid or the side of the tube, but not too far into the liquid, because then you'll get stuff on the outside. Then push down to the second stop and draw out with your thumb still held down, so you're not bouncing things back up into your tube. And make sure you look before and after to make sure that the liquid got into the tube and got out of the tube and the volume that you thought there was. So you want to make sure when you're pulling up that you don't have any bubbles in. Those are that. When it comes to working with the multi-channel, there's another thing to keep in mind. So with these multi-channels, when you draw down on your sample, so basically you just, okay, so when you're grabbing your pipette tips, you want to make sure that you're evenly distributing between the different edges and coming up. So sometimes it's easy to like kind of, especially if you're doing it at an angle, what happens is that when you draw it, it'll be like partially in on some sides and not all the way. This is going to make it so that either they're not all stuck, or you're going to have some of them that are going to have more volume than other ones, and none of those things are good. So you want to make sure that you have an even distribution, and then also when you're drawing up the liquid, you want to make sure that the lines of the liquid are even. Sometimes some of them will be off. This can happen especially too if you're using like a well or something and there's like a bottom, like there's a bubble in one of them. So what you want to do is go up and down gently to try to get rid of the bubble, before trying, so that you have them all at the even volume. Speaking of even volumes with the multi-channel, if you don't have a full like width you want to do, it's best to use the middle of the multi-channel. That's going to be the most accurate. Instead of using like half of a side or something, use the middle. That'll be the most accurate, the most even distribution between them. Then, yeah, and so you can set up your pipette rack or whatever to have how many samples you need in order to do that, and then you can just move it from place to place if you need to when you're organizing your rack. It's always good to keep an extra empty rack, so that when you're doing your rearrangements, you have somewhere to put the ones that you just took out. So some people would probably like be horrified by my pipette tips rack. Some people are really particular about it, but I kind of just grab anywhere. But if you are trying to keep track of where you are in like the number of samples, it could be helpful to go in order. Say you're doing like 8 samples. If you have, you forget what number you're on, but then you count how many pipette tips you've used from the side. So that's another tip when you have a lot of things. Peter pipettes are going to come in a variety of different sizes, and the sizes are going to be this tip. So this part's going to be the same for all of them, but these tip sizes are going to be different, and the smaller the tip size, the finer the gradations that you can do. To load one of these, you push down, and then you're going to draw up. When you draw all the way up, now you're going to, there's going to be a little extra liquid, so you want to squirt that out. And then you go down, 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 and each time you go down, it's going to go down by a set amount. Don't trust like that first little bit, so a little bit just excess after. And also be aware that at the end there could be bubbles, so when you pull up, you typically want to make extra so that you don't have any bubbles, and then you don't have to worry about that, and your last sample will still be good. Your last release will still be good. If you've drawn up some bubbles, then you could have problems with that last release. And yeah, so based on how many, the size or whatever, the gradations that you can do are going to be different. It'll have different set levels. Like some of them might be 1 microliter, but some others will be only 10 increments of 10, others will be increments of 50, that sort of thing, depending on the size of one of these. When it comes to the serological pipettes, you also want to use this lowest volume, and this is a couple of reasons as well. One is that the gradations are going to be closer together. So if, for example, we compare this 10 milliliter serological pipette, it's kind of confusing because they call it 10 milliliters, but then you can see that it actually goes up to, there's like 3 above it. It's like -1, -2, -3. So you can actually go up to like 13 microliters in here. You can also see this, so this is a blowout pipette, which means that you can see that from like 9 to the bottom, it looks a lot longer than these. That's because it's narrowing down. And so when you deliver with these, you're going to actually blow everything out of the tip. And so because it's graduated, I don't know, because it's narrowing down, you're going to have a longer volume to push things out. But you can see that for this 10 mil, we have 10 mils in 1 to 10. So this means that these lines are going to be 1/10 of a milliliter. If we were to go and look at the 50 milliliter, well, now we're at 1/2. So each of these lines is only 1/2 of a milliliter. These lines are going to be serving as your like guideposts when you're trying to measure. Unlike the micropipettes where they have like set, like it tells you, like you adjust the dial and it'll tell you, okay, you stop here, or like it'll push down to the part, it'll set the volume basically. But with one of these, your job is to set the volume based on these lines. And so you want to, when you're using one of these, you're going to be sucking the liquid up so that the line, the meniscus of the line, so the like curved part is going to be at the bottom. And so you can see here that I've got 3 microliters. I keep saying microliter when I mean milliliter, so hopefully you know when I mean milliliter and when I mean microliter. When I'm working with those serological pipettes, I'm talking about milliliters. When I'm working with the micropipettes, I'm talking about microliters. Unless I'm using a P1000, well, the 1000 is still in terms of the microliters, but you can go up to a milliliter. My meniscus is like the bottom of it is on top of the 3 microliter line. If you turn this, you can see that it's going to tell you 7. So these serological pipettes, they have on one side, they have like counting up, and then on the other side they have counting down, which can be really helpful unless you accidentally think you're on the counting up side if you're on the counting down side, or vice versa. But you can get a much finer separation, much better precision with one of the smaller volumes. The smaller the volume is, the finer the gradation. So a 5 mils, you're in 1 to 10 still, I guess. If you go to a 1 mil, now you have 1 to 100, although for most purposes you would, unless you have something that's really long, say, you would probably be using a P1000 if you were trying to do something like that. But the key thing with these serological pipettes is you want to look at the meniscus, and the meniscus is going to be right above the line. What can get kind of hard is that the meniscus is going to be that way if you're looking at it like straight on. Often when you're pipetting, you're going to be at an angle. And so since you're at an angle, your meniscus is going to be angled too. Typically what I do is, if I don't care too much about like how exactly accurate it is, I'll just try to get like, so I'm at an angle where the meniscus is going to be like right at an angle where the halfway point, like it'll be halfway, kind of like a seesaw that's halfway, and that will be good enough. But speaking of good enough, often when we're doing things, we have to kind of think about, okay, well, how much do I really need that extra precision? If you don't need that extra precision that much, it's okay to just like eyeball it like that. But if you do need the precision, then you really want to make sure that you're measuring really correctly and making sure that, say, okay, maybe I should use the smallest pipette that I can use. Whereas if you're just trying to transfer liquid from one place to another, you really don't care that much about the accuracy, and maybe going in 1 ml portions is good enough for you, and you don't even need to eyeball it that accurately. It's really good to like know what each step in the experiment does, and then you know when it's okay if you're not as precise, or when you need to be really precise. And so that's one of the reasons why I recommend that everybody, like, that you really appreciate how a protocol works, and like what each step does, and that is going to help you be effective and not be like, oh, but the protocol says I have to do like exactly 598 microliters. What if I do 500, and what if I just do 600 microliters or whatever? But often if a protocol is giving you like a really specific number, it's probably like something that you should pay attention to. Normally they'll just be like, say it's like 600 or 700 or something, and then you know that it's okay, there's a little fudging. Same with times, like if they say 60 minutes, that's more like specific than saying like an hour, typically. But then again, you still have a little bit of wiggle room with the larger time points, typically. But if it's not like a time course, if it's just like some incubation step. But anyway, that's getting off topic. So back to pipettes. But when we're doing these really small volumes, when we're pipetting things like the micropipettes, we typically really do care about that precision. We care about how fine we can get with these measurements. One thing with the pipette mins that you use with the serological pipette, basically this is just replacing one of those like sucker things in one of those bulbs. So all it's doing is just like pulling liquid up. It's going to pull up until you tell it to stop, and you're going to tell it to stop based on the lines of one of these. And remember, the smaller the pipette size, the thinner the narrower this is going to be, the more space between the different lines, so you can have finer gradations than you would have with one of these. And so you can think of that meniscus is going to be, when you have one of those thinner things, you're going to have a more distinct meniscus. With one of these big ones, it can be kind of hard to actually see the meniscus. But again, when you're using one of these big ones, you often don't care that much about exact precision, especially because if you're a little bit off, it's just going to be like a drop in a bigger volume as opposed to a drop in a smaller volume. So yeah, we often use these just when we're like transferring large amounts of liquid from place to place, and we're not as concerned about the precision. When you use one of these, some of them are fancy Nancy, and they have different like you can set them to have different speeds. This is really, really important, especially with like cell culture, that you're not going too fast and just like killing all your cells. So you can set the speeds for like the up and the down. So for coming up, you might want to go faster. Then you're coming down, you want to go slower, because you don't want to kill your cells. But when you're going up, you don't want to spend forever like pipetting up all of that media, the food that you want to feed your cells. And so yeah, so if you're lucky, you'll have one of these that has like this thing. They're also like the ones that you basically dial up and down, instead of having them be battery operated. Speaking of the battery operated, make sure you charge them, because it's awful when you're in the middle of the experiment and the charger dies, or it runs out of charge. We also don't want bubbles when using a serological pipette. So although we need to blow out in order to get the total volume, if we're really, really worried about introducing bubbles, what we can do is we can calculate. So we go up, so say I wanted to pipette 10 microliters, I could go to the 11, or that's a bad example because that's like above the line. But say I want to pipette 9 microliters, I could actually go to the 10 microliter line, or milliliters. I can go to the 10 milliliter line, but then only dispense out to here and avoid having to do the blowout, and avoid the bubbles that way. This can be good if you're doing like cell culture work where the cells are really sensitive and you don't want to introduce bubbles when you're doing that. Don't store your pipettes like upside down. It might be easy when you're trying to get your hands to try to open a tube or something and put it upside down, but then things can drip down into it. But you should not be reaching for that tube, because you should have everything ready to go by the time grab this. So don't go upside down. Keep your pipettes right side up. More note is when you're opening like the individually wrapped ones of the serological pipettes. So these some come like individually wrapped, which are especially for like cell culture really important. Others come in bulk, so they're just in bags. When you're opening them, you want to make sure that you're opening the side with the plug. So basically, you can just push through here. You want to make sure that you're not opening the side of the tip, because then you're going to get touching the tip, and that's not good. So open the side with the plug and do this, but after you've gotten everything else ready, then when you're finally ready to pipette, you've got all the tubes loosened and everything like that, then you can do your push open, push out, and then you want to pull just directly out and not like grab it all, wave it all around. When you're done, you can then put it back in its home. Voila. Okay, those are the basic things about pipettes. As I talked about in yesterday's post, you also have this idea of filter tips. So you also see filters in these serological pipettes, especially because when you're just sucking up, if you suck up too far, it could get in here and damage this. And so there's a filter here to make sure that you're not sucking up too far. And then when you have filter tips on your pipettes, it's going to help any liquid that splashes back up, and then it's also going to protect what's in your tube from whatever was on the tip of this pipette. So we use them a lot when we're working with RNA, to keep out RNases and also contaminating things from the tip. If we're working with another sample, say we're maybe within qPCR or something, we don't want that to happen. When you are mixing, so another way to avoid bubbles is sometimes you want to mix solutions, or you want to pipette into a solution and then mix the solutions. So I like to go up, down, up, down, up, down, up, down 5 times, and then on the 5th I'll pull out or whatever. You don't want to go outside of the liquid, so do it all in the liquid and don't go down to the second stop. Just keep going on to the first stop, up and down and up and down and up and down. Don't draw out. That has a chance of introducing bubbles. We don't want bubbles. When you're mixing with a serological pipette, you want to make sure that you're not drawing up air. So when you go up and down, don't let all the liquid out at the very bottom. Just keep a little bit, and so that you're not actually getting air out. Or if you do go all the way out, make sure you're not getting bubbles. Basically, you don't want to just keep it all in the top, because then you're not going to be mixing, but you want to kind of just go all the way down to the bottom and all the way back up without actually getting any air or introducing any bubbles. First, you can be really, really shaky when you're pipetting. A good way to practice is just pipetting water onto a balance, and seeing that you're getting the same amount each time, and that amount you can then calculate and does it really match the density of the water, or am I really pipetting the volume I think I am? It might not be your fault if you're not. So if you were to test this and how close together each of those different tests were, that would be an measurement of your precision. So how close together the values are. So the precision is also going to depend on another way of defining precision or whatever. There's a couple ways. But one is how many digits can you get on your pipette? So your precision is the precision that you can think you have is based on the pipette in a way. But then how close together all your individual pipettings are, that would be a measure of precision. So I think of picking the tail of a donkey, how close together those donkeys' tails are would be precision. But what if you're not actually on the donkey's tail, you're on the donkey's head, even though they're really close together? That wouldn't be accurate. So accuracy is going to depend in this case on how accurate your pipette is. So every year, typically we get our pipettes calibrated. So we just got our pipettes back from being calibrated. So they test, then make sure that the volumes that the pipette says it is really the volume that it actually is. And then you have the issue of how accurate you are when you're actually doing things. And that's the basics of all of these pipettes, and how you use them, and some specific things to keep an eye out when you're using different types. And yeah, so now my thing is probably chilled, and I'm ready for my experiments. So hope that your experiments go well, and if you're starting out in the lab for the first time, I wish you the best of luck. Well, I wish all of you the best of luck, but lab life can be really fun. But there's a lot of different tools that you have to get used to, and pipettes are a main one that you're going to have to learn, and so hope this helped.